new one. We're going to determine whether the series is convergent or divergent. So let's first write this as f of x equals x times e to the negative x power. Now we're looking to see if our f is continuous and positive here. It is. For decreasing, let's take our derivative of f of x, and that's going to equal negative x e to the negative x power plus e to the negative x. We can simplify to e to the negative x. You're just factoring out e to the negative x. This is 1 minus x, which is the same as 1 minus x divided by e to the power of x. This is less than 0 or negative when x is greater than 1, because our interval is from 1 to infinity. So that means our f is decreasing on this interval. So we can apply this integral test, and that's what we're going to do. And we're basically going to take the integral from 1 to infinity of x e to the power of negative x. And to save some room, I'm going to go ahead and integrate this real quick on this slide, and then we're going to continue on with the integral test. So I'm going to do tabular integration. So if I write an x here and e to the negative x power here, what you do is you copy down your x, take the derivative, and then a derivative of 1 is 0. And then you do the integrals all the way till we get to 0. So this is, you copy down e to the power of negative x. So you get negative e to the negative x. And then this is going to be e to the negative x power. Then you draw these lines. You could also do integration by parts if you find that easier. So this is going to be plus, minus. So when we integrate this, we're going to get e. If you multiply these two, this is going to be negative x e to the negative x power minus e to the power of negative x. So just keep that in mind. That's our integration, tabular integration. Now let's go ahead and set this up the correct way. And we're using this one right here. And we're going to write this as the limit as b approaches infinity. And now we're substituting our infinity with b. All right, so that's what we have here. And our function is x e negative x power dx. So this is going to be the limit as b approaches infinity. And then we already did the tabular integration. And this was it. And this is by tabular integration. You could have done integration by parts. All right. Now let's see what we can do. So this is going to give us the limit as b approaches infinity. And now let's substitute in b. This is going to give me negative b e to the power of negative b minus e to the negative b power. And then for the 1, and don't forget we're supposed to subtract, but I'm going to, 2 negatives make a positive. So you're going to get plus e to the power of negative 1. Another thing, 2 negatives are going to make a positive. So positive e to the power of negative 1. All right. So basically this is going to equal 2 divided by e. All right, because we have 2 of these. Now, I want to look at this real quick for here. So looking at this, I want to show you why this is going to go to 0. This is going to be 0. And you have 1 divided by e plus 1 divided by e. The reason this goes to 0, so this is where it converges to, but the reason it goes to 0 is by using L'Hopital's rule. So if you use L'Hopital's rule, we'll take the limit as b approaches infinity of b times e to the negative b. So this is going to equal the limit as b approaches infinity of b divided by e to the b power. Now, using L'Hopital's rule, you differentiate the limit as b approaches infinity. The derivative of b is 1, and the denominator is still going to be e to the power of b. So that's why it equals 0. But again, our series n equals 1 to infinity of x to the power, let's just write it as n to the power of e to the negative n power converges to 2 divided by e. Thank you. Have a nice day. Bye-bye.